All right, welcome to the next video in our series of integration. So in addition to our previous video where we were doing the concept of integration by parts, I think it is quite useful to do just two more examples of this concept of integration by parts, just so that you can consolidate your understanding of it. So what I'll do, just to remind you again, so we use integration by parts when we cannot use U substitution or any of the other methods. I'll put a star here on this question D because it is quite a unique question to do, but we'll get to it shortly. So remember how we use integration by parts. You cannot do any U substitution here, so we use integration by parts. So in our case, we will let the function f of x equals to 3x, and then we will let the derivative become cos of 2x, and therefore here, if we wanted to find the derivative of that, we get 3, and here if we wanted to get g of x, getting g of x is equivalent to getting the integral of cos of 2x, so therefore you get 1 over 2 the sine of 2x, and that's how we do that. And therefore we can now come and apply our integration by parts now. So the way we would do this, I'll continue to rewrite the question. So this is cos of 2x dx, and I want you to be able to notice in this question, this is going to be f of x. Again, this now becomes the derivative. So therefore, we are now in a position that we can use our integration by parts. The formula for integration by parts is up here, and it is given to you in the further studies formula sheet. So therefore, to do this, remember we would then go f of x, so we would then go 3x multiplied by g of x, which is in our case sine of 2x, and then this becomes minus the integral of g of x again, which is that, and then we multiply that by the derivative of f, which is 3 in our case. So therefore now I'll continue the problem here. So this becomes 3 over 2x, the sine of 2x, minus the integral of that. So this is the same as going minus 3 over 2. And then we have to integrate the sine of 2x. And I think once we're at this stage, you should now be comfortable with doing this particular question, because I think you now well versed and know what the integral of that is. So the integral of this will just become cos of 2x over 2 plus our constant of integration, and therefore simplifying this gives us 3 over 2x sine of 2x minus 3 over 4 the cos of 2x. And that's it. Integration by parts. I think once you know these techniques, it is much easier to solve the problems. Now let's dive into this one over here. And the reason that this is a bit of a challenging question is that it requires to do integration by parts twice in the same question. So let's start with the first one. So in our case, we will let f of x become this function x squared. We'll let the derivative of g become e to the 3x. And then from here, I think we can work out that the derivative will be 2x, and here g of x will give us minus 1 over 3 e to the negative 3x. And then using integration by parts, I'll write everything now in red. And using integration by parts, where we get to do this function, which is x squared e to the minus 3x, this dx. So this will then give us f of x, which is x squared, multiplied by negative 1 over 3 e to the negative 3x. And this will be minus the integral of negative 1 over 3 to the e to that, and then we'll be left with 2x dx over there. And then simplifying this gives us minus 1 over 3 x squared e to the minus 3x. This will give us a plus there. And I want you to notice something again. So if we were to just rewrite this expression again, this will be the integral of 2 over 3x e to the negative 3x dx. This part over here looks similar to what we're doing in question 1. So we cannot use substitution. We cannot simplify this further. So therefore, we apply integration by parts again. So this is a short form of saying integration by parts, IBP. So we have to use integration by parts again here. And just to save some space, I'll just do it here on the side. In our case, I'll let f become 2 over 3x, and therefore its derivative will just be 2 over 3. And then we'll let g of x equals to e to the negative 3, the derivative of that, and therefore g of x simply becomes 1 over 3 e to the 3 to the minus x. So this is quite a special question because you had to do integration by parts twice. So now let's get back to the question, simplifying that. So that becomes plus. In our case again, we'll just do f of x. So this is 2 over 3x times minus 1 over 3 e to the 3x to the negative 3x minus, we'll now do our integral. So there's the integral of minus 1 over 3 e to the minus 3x. And then this becomes 2 over 3 dx. So now we don't have an x anymore. So therefore, we have completed our integration by parts. So let us simplify this. This becomes minus 1 over 3x squared e to the minus 3x. I think you'll only get a question like this if the examiner is trying to be very mean to you guys. I don't know why the examiner would do that, but it is doing integration by parts twice, so maybe the question is not necessarily more or less difficult. But it is quite a beautiful question to do. So let's continue again. We have to find the integral of that. So this becomes 2 over 9, and this becomes the integral of e to that. And I think simplifying that, it now makes sense that this becomes our solution is given by this minus 2 over 9x to the minus 3x. Again, I think this last part will be a minus again. This will be a minus. If you do the math, this becomes 2 over 27, and this becomes e to the minus 3x plus c. And yeah, that is it. So that is how you do integration by parts. I've done 2 more questions, with the last one being a slightly more involved, slightly more difficult because it uses integration by parts twice. I hope this has solidified your understanding, and we are coming to the end of our series. So I think we've got like 1 more or 2 more videos, and then we will have completed our series on integration. So see you in the next video.